So I will talk about, in a way, that's the one talk we're going to move away from React itself. And oftentimes people, this is a quote from React documentation, which says many people choose to think of React as the V in MVC. But of course, for larger applications, you can't really get away with just the V of MVC. You need those other parts. And I want to talk about what are some of the approaches that we can take to this, to building the deeper layers of our front-end application, and make a case that Redux is probably the best way to do that today. And so we'll talk a bit about the context for this, of what some of the alternatives, and also dive deeper into Redux. So before we launch into this, let's talk a little bit about when people say the V in MVC, I mean, what does that even mean? I mean, the word MVC is used often today, but I think people don't often think about what it actually means, right? So if we think of MVC in theory, right, here's how MVC is supposed to work. You have a user, here's your happy user. Everything in the slide is pink because in theory, MVC is super happy, right? And there is an underlying model, right? So this is some data that the user wants to interact with, right? And the way the user is going to interact with this data is it's going to get projected to the user through a view. So this is going to be some display of that data. And then there's going to be some method for the user to manipulate that. This is going to be through a controller, right? So the controller is basically some widgets which allow the user to modify the data, and the view is some way of displaying that data, right? So this is how MVC works in principle. And the main idea here, and this is an idea that we want to preserve, is first of all is a separation of concerns, right? The model, the actual representation of the data of our business logic is nicely separated from any logic around displaying that data or collecting users' feedback. Now, this is kind of an ancient model, and the separation of view and controller in the kind of modern sense doesn't usually happen that way, because we usually don't have two entirely separate pathways. Though you actually might see here there's a little bit of it looks a bit like a unidirectional data flow. So in some ways, we're actually going to get back to something down later in this talk that is going to actually have some resemblance to it. But in practice, when people talk about MVC today, that's not usually what they end up building. What they usually end up building ends up looking a little bit more like that, like the following. So first of all, few people today really use proper MVC approach. What you more often get is something that would be called the model view model model view approach, right? And where what you have is you have your view that's usually abstracted. A lot of this is handled in the browser. Then you have your view model, which is the kind of the data representation of that's prepackaged for consumption for display, right? So for instance, if you're using Angular, then this is going to be the data that's stored inside of your controller, right? So there's kind of with classic Angular, there's a little bit of awkwardness around the fact that your controller in many ways is actually a view model. And then you have the deeper underlying representation of the data, which is your model, right? So in this case, the model is the kind of the business representation of the data that usually stays more or less, the structure of that stays the same throughout the life cycle of your application. The view model is whatever it is that you're looking at the moment, which is in many ways a projection of the data in the model. Right? And then the idea is that the view model also allows the user to go and make some modifications. So what you have is that there is basically some command flow from view model to the model, and then you have some command flow back. And at this point, we actually still have nice separation between the deeper business logic and the view part of the application. And it starts getting a little messy, however, as our application gets bigger. We add another view model, and then we have another. So you can think of those as components, right? With usually they would often have state, representational state in them. And then we have like a bunch of them, and then we start also breaking up. Our model is complex, so there's many parts to it. And then what we start seeing is that, well, as one model updates, different views need to be updated, and then as things happen in the view, the different models need to be updated. And eventually you end up with something that looks more like this, and this is sort of your kind of like MVC today in practice, right? And this is assuming that you don't have view models talking to each other, which is, makes things even worse, right? So this is like practically what you usually end up with. And that's not happy. So so now an interesting thing is that if you've been talking about React actually gives us a partial solution to this, right? That actually, I mean, it's a partial solution, it doesn't solve everything, but it actually goes a long way towards stopping you from having a mess that looks quite like that, where you have a whole bunch of different pieces of view logic hooking into a whole bunch of different pieces of your underlying business model, right? And the main idea so from React is the idea of isolated, or sometimes people call them dumb components. That are nested in a child to parent kind of way, where the important sort of characteristic of that nesting is that it's very strict in terms of how the component interacts, so how the child interacts with the parent, right? So the idea is that we want to be really, really strict about that, where the child strictly takes inputs from the parent in React in the form of props, and it sends information back to the parent by calling callbacks, which are passed to it as props, and that's it, right? So in this sort of model of an isolated component, that's the only way that the child interacts with anything. First of all, the parent component is the only thing that your child component interacts with, and that's the only way through which this interaction happens. And I mean, this is really great, and you should, generally speaking, maximize the use of such dumb components. I mean, anything that can be implemented as a dumb component probably should be implemented as a dumb component. And let's talk briefly about why, because once we understand why, it actually makes it easier for us to think of how do we want to deal with the actual business logic down the line. So the advantages of those components, of isolated components, is first of all, it helps with code reuse, right? Because your components are isolated, they're not context specific, right? So an example of such a component, think of a date picker. A date picker that has no idea what's the meaning of the date it's picking, right? It's basically just, it's sitting there, and its goal in life is to allow the user to pick a date. It takes some input in terms of what's the part of it that's, like let's say what date range it starts with. It may take some inputs in terms of what dates are blocked off, but ultimately the user clicks on something and selects a date, and then there's a callback gets triggered and the parent gets notified, right? So the great thing about this is that if you have a date picker component like that, you could drop it in anywhere because it has no assumptions about where it lives, right? So that helps with code reuse. That's one great thing. Now, the second thing is that it helps with testing. The reason it helps with testing is because, again, your component makes no assumptions about anything else, and because it makes no assumptions about anything else, in the context of testing, all you need to do is just instantiate it, send the right inputs, check that you get the right outputs, and you can actually then feel fairly confident that that component is going to work in any context. A component that is context-specific, you need to actually test it with that context in mind. And finally, it makes it a lot easier to reason about your code, right? And the reason, again, is because you can actually understand what this component does without understanding the rest of the application. Now, it's worth, however, to think about what are some of so there's those three benefits, but it's worth thinking what are some of the sources of them, right? And one source that we get those three benefits is isolation. That's one thing that I've mentioned. So because the ease of testing, the ease of understanding the components, and the ease of reusing them come from the fact that they are separated from the rest of the application. But the second reason we actually get a sort of a second helping of a lot of those benefits has to do with something else, and that is the fact that in React, dumb components are usually mostly stateless. Now, this mostly stateless part is we need to talk a little bit more about. And let's take a moment to think about what's the problem with things being stateful, right? So, I mean, a lot of us, maybe some of you are younger, but a lot of people in my generation, we grew up on the idea of object-oriented programming, and it's sort of very easy to default back to object-oriented programming kind of thinking. And the key idea of object-oriented programming is that objects are stateful, right? And objects are stateful. That what this means is that the effect of calling a method on an object really depends on the arguments and also the state, right? And this makes testing a lot more painful because you cannot just send arguments and check the output. You need to actually put the object in the right state, and a lot of this sort of goal of object-oriented programming oftentimes is to not let you actually put the object into an arbitrary step, so you have to jump through hoops to actually call methods in a particular way before you get the object into the right state, and then you can actually only call the method that you want to actually test, so that makes testing complicated. And it's hard to understand because, again, you cannot think of it, of your objects as simply you get this input, you get this output. You have to think of how the state is represented. And at this point, you sort of almost even start wondering, like, well, how did this ever seem like a good idea? And I mean, the way it got sold to all of us is that it mimics the real world. But the truth is that it actually doesn't, because your button that doesn't work like the real button, and your employee record doesn't work like an actual employee out there at the desk, right? So you basically end up replicating unnecessary complexity, and you don't gain much. So the alternative that we want to go with, in many cases, is pure functions, right? With a pure function, the idea is that the output of a pure function depends only on inputs. Second is pure function has no side effect. So the idea is that the only effect of calling that function is the value that it returns. Now, why is that great? Well, it's much easier to understand, it's much easier to test, and also you can actually build complex behaviors through composition. So now all of this is, you've listened to a day of React talk, so I'm sure that this is not revelation, but I wanted to rehash that quickly because a lot of the things that we're going to talk on is going to actually build on that, because one of the great things about approaches like Redux is that they actually philosophically align very, very closely with a lot of the other kind of basic assumptions of React. So an interesting thing is that you can actually, in React, not everyone sometimes is familiar with that, but you can build in React, you can build fully stateless components. Fully stateless components, you implement that as a function, which really all it does is that it takes props and it returns DOM, right? Or if you want to write the same thing in ES6, then you would actually even just get this, right? So this is your most basic component in React, which is a hello message, which takes props, it includes a name, and it just gives you back hello. And such components, again, so like when you can implement your React components this way, please, please, please do that. And one of the actually sort of great things about Redux, as we'll see, is that it allows you to actually greatly expand the number of cases where you might have thought of using state in your components, but now you actually don't need to, and your components can be purely stateless. Now, okay, so this is wonderful. So we sort of bought into this idea that doing stuff in a stateless way is wonderful, and React allows us to do this really in a great way, where we have those components which are purely stateless. They just hook into the parent, they get props from the parent, they call the callbacks to send information back. They have no state whatsoever. Okay, so but now where does the business logic go at the end of the day? So let's rethink of it. So each component gets the props from its parent. Each component transmits actions. Okay, to the parent, to the parent, to the parent, but what do you get at the end? Is it like sort of turtles all the way down? Or in this case, it's like turtles all the way up, right? Like at the end of the day, you get to a component that has nowhere to transmit information, right? And no one to get it from. So what can we do? Right, so it's like turtles all the way up, right? So the answer is that, therefore, your top-level components, some of your components need to be a little bit smarter than that. Right? It's really good to try to make as many components as you can isolated and stateless, but you cannot obviously do that for all components. So let's talk more about those components, and we're going to call them container components. So in particular, how do we link containers with models? Well, here's an idea. So we have a container, and we have something that represents the business logic state, and we're going to call it a model, and the container will update the model, and the model will update the container, and then when we have another container, we add another container, and when we have another model, and I was like, wait, never mind, right? That's what we started with. That's what we've kind of really wanted to avoid, right? That's not the way we want to go. Okay, so what are some of the other alternatives? Well, maybe we could use the container. React components can have state. So maybe we could have our top-level container components, maybe we could just leverage their state. Right? They could store the application information there. Well, we could do that, but I mean, that's so much for separation of concerns between views and business logic. Well, so what if we were thinking of like what would be like a React way of doing this? And here's actually kind of a plausible approach, right? So we're going to have a container component, that's our top-level component that has no visible parent, and we're going to embed it inside of something. And we're going to actually make it talk to that parent, that invisible parent now, in sort of the same way that React components normally talk to their parents, which is it's going to get properties and it's going to call callbacks. And we're going to call this parent state container. So this is roughly the approach that we're actually going to be going for. And if we were to go ahead and rename props to change events and callbacks to actions, we get the basics of what people call Flux architecture, right? So the idea here is that we put most of our view logic into reusable components. Eventually, we assemble a larger component that has a connection to the business logic, but the way that a container component connects to the rest of to the business logic side of the application is that it listens to change events and it emits actions. I mean, actions is sort of similar in this case to calling callbacks. So, and the idea is that we actually still have, so we have this unidirectional data flow right here, but notice that this unidirectional data flow, it's not something that suddenly we've got this new idea. I mean, this is something that we've actually have been following with smaller level components all along. So how do we handle data inside of this state container if we were going with Flux? Well, the way we would do this is we have a bunch of components, and components emit actions, and actions are really just snippets of JSON. I mean, they're small JavaScript objects that describe what is it that happened inside of the component that the component wants to let the rest of the application know about. And those actions are caught by a dispatcher. So a dispatcher is basically a component that a module that basically collects all of the actions and just sends them out to whoever needs to be notified about them. And then the next step is the dispatcher notifies stores. So in Flux, you have several units that basically keep track of your application state, and they're called stores. Usually you have several of them. Stores keep the actual state of your application, so the business logic state. And they then send this out to components. Right? So then this way everyone actually gets to update it whenever you have an update. So the user clicks on something, there's this button click gets translated to an action goes to a dispatcher, a store catches that and makes some adjustment to the state, and then this gets sent to the components in the form of new props. Now, in practice, it often ends up being a little bit more complicated because you need to do silly things like HTTP calls to a server and those kind of things. Right? Basically, oftentimes at the level of processing your business data, you actually do need side effects. So one way to do that, and we'll actually look later at a better way, is to go through an intermediate step called action creator. Right? So an action creator is a function so the component, instead of actually creating a JSON snippet and sending it somewhere, will just get a function to call, like a callback you can think of, when something happens. Right? So for instance, when the user wants to increment a number, we'll have an increment number function. When we call that function will be responsible for creating an action. And in the simple case, it will just simply issue an action and send it to the dispatcher. But in a complicated case, it could do more. It could, for instance, make a call to an API, and then it could issue an action early to notify everyone that a call is being made. It could then later issue another action to let everyone know that the data came back, or it can issue an action to let everyone know that the call failed. So those now multiple actions in response to this invocation end up hitting the dispatcher at different points in time, and then the rest of it actually proceeds the same way. The dispatcher notifies the store, and then the store updates the components. Right? So this is kind of basic Flux. Right now, Flux, there's a bunch of implementations of this, And you could think of Redux as an implementation of Flux. It's a little different from some of the earlier versions of Flux, but only in the sense that arguably it takes Flux to its logical conclusion. And again, with this picture, we'll actually see a better way of doing that in a second, or a little bit down the line. So now let's talk with this somewhat lengthy introduction. Now let's turn to actual Redux, but hopefully as we actually get into Redux now, everything about it will make a lot of sense because we understand the context. So Redux is effectively a better state container. It's an approach that's very much aligned with everything I've described, but it actually makes a few extra improvements. So you can access it on GitHub under Rect Redux. And it's actually today, I would say, pretty much the dominant way of doing Flux with React. I mean, so really, I think at this point, and if you're using React, then this is, like the way to do that. I don't think we were talking about this for a while. We have to sort of tell people like, like it's great, it's new. At this point, it's not really that new anymore. This is the way. I really strongly recommend this. And the key ideas of Redux that Redux adds, in addition to everything I've talked to before, is an idea of using a single store and state reducers. Now, at this point, you might ask, well, how can a single store be a good idea? Because that sounds scary. That sounds like we're kind of moving into some kind of single shared representation of everything. And the second thing is, what the heck is a reducer? So let me actually talk about the second part first, of what are reducers. So we'll need to dive into a little bit of functional programming because reducer functions Redux reducers are really effectively reducer functions. And reducer functions, they're like one of the basic functional programming operators that somehow doesn't get quite as much love as map and filter. I mean, everyone uses array.map, everyone uses array.filter, hopefully. But sometimes people forget about array.reduce. So let's talk a little bit about how that works. So let's imagine we want to write a function that we want to write code that goes and adds up all the numbers in an array. So the way we could do that in JavaScript using array.reduce is by implementing a function that we're going to call add one value. And this function is a very, very simple function. It's a pure function, and we've talked about how awesome pure functions are because testing this is really very simple. And it takes a value, and then it takes a state. And the state is really like what number are we at now, right? So we're going to if the value is 1 and the current state is 15, then the function is going to return 16. It adds the value to the state, right? That's all it does. And then, but now, of course, we could actually have reducer functions that are potentially more complicated and do something else. But in this case, we're going to stick with something very simple. Value and the state get added together, and the next state is returned as the sum of those two numbers. So if we now want to add up numbers 1 through 5, we're going to call array.reduce, passing add one value as the first argument and passing 0 as the initial state, right? And let's just walk through this so that everyone understands how this ends up actually giving us the sum of those numbers. So what array.reduce is going to do is it's going to start by calling add one value, passing as the first argument the first item in the array, which is 1, and the current state, which is 0. The initial state is 0. That's the second argument to reduce. And the add one value is going to give us 1. For the second iteration, we're going to take the second item in the array, in this case 2, and the current state, which is 1. We're going to run them through add one value. It's going to add them up. We're going to get 3. For the third iteration, we're going to take the third item in the array, 3, and the current state, which is 3. We're going to add them up. We're going to get 6. For the fourth, we're going to take the fourth item, 4, and the current state, which at this point is 6, and we're going to get 10. And then finally, for the last iteration, we are taking the fifth item in the array and the previous state 10, we're going to get 15, and that's the sum of numbers from 1 to 5. Right? So this is functional reduction, right? Where we basically wrote a function that takes the previous state and some modification, and based on that derives the new state, and then we run this over an array, and we get to the state that we want to be in. So action reducers in Redux are basically reducers over history of actions. So the idea there is that sort of the key component of Redux is a function called a reducer that takes an action, and actions I mentioned before are sort of little snippets of JSON, which basically describes what happens. So each reducer takes an action, and it takes the previous state of the application, and it returns the new state. It's really that simple. And what's cool about this is that your app state is a reduction over the history of actions. And you might wonder, well, what's so great about this? But what's great about this is that it means that we can actually always recalculate your state. And this gives us actually access to a bunch of really cool tools that I'll demonstrate in a second. So each reducer now it doesn't need to actually operate on the full state, right? So your application effectively is this one giant tree of data, but your reducers don't need to operate on the whole thing. They could subscribe to only a subset of that. So basically, they get a pointer somewhere into your tree and an action, and they return the new version of that. And then finally, you can take such simple reducers and you could combine them into more complex reducers, right? So in this reducer becomes the basic unit of your data processing approach. So let me show you how this works. But first, let's quickly look at creating an action, because I just want to make sure that everyone is on the same page about what's an action. So an action is actually something really, really simple, and this is an action following the Flux standard action pattern. So it's a JavaScript object that has a type, where type is a constant that identifies what's the type of that action, and then it has a payload which has some data. So in this case, we are building a note-taking application, and every time the user enters new content into the note, we're going to issue an action that's where the type is update note content, and the payload specifies the note ID, the ID of the note we're changing, and the new content as a string. Right, so that's really all there is to it. Right? It's really a function that takes note ID and new content and creates this really simple JavaScript object. And by the way, if we are switching to ES6, we could actually write all of this way more concisely. And of course, since you've been here through the day of React, I'm sure you've seen a lot of ES6 by now. And I mean, writing React today without ES6 is really just not worth it. So it becomes even more concisely because we can take advantage of error function and a few other features. So now here's how a reducer then works. So a reducer in this case needs to catch those actions and in return to and update the state. No, sorry, not update, but actually derive the new state. And this is sort of I see myself sometimes fall into this trap of actually saying update the state, but remember that we actually do not want to ever make any changes in place. Every time we take a state, we add an action, and we generate a new state. So in this case, we're creating reducers using a helper function called create reducers, and we pass to it an object keyed by action type. And for every action type, we specify a function that's going to get triggered when that action is matched. So in this case, we're saying that when our reducer catches update node content action, it will take, we're going to then call the function that takes the previous state and the new action, and we're going to generate a new version of this state where the node with the corresponding ID has its content, its HTML content updated to the new value. And we'll talk in a second of why we're doing it the funny way with state.set, but for now, let's remember that really all we're doing is we're taking state and action, and we're returning a new state. And if you're not super comfortable with ES6, this may be a little bit easier to understand if we go with a bit more of an ES5 style syntax, where basically what we're doing, again, so we have a function that takes state and action, and it returns a modified state. So now, why is this a good idea? Well, there's a number of things. First of all, reducers in this model are pure functions. And because they're pure functions, they're really easy to understand, and they're really easy to test. I mean, they're so easy to test that I've promised you to actually talk about how to test Redux, but my testing is just one slide in the end. It's really easy. Second is, and this is kind of amazing, reducers are synchronous, right? Now, I mean, in JavaScript, we kind of learned that nothing is synchronous, right? That you really cannot program JavaScript effectively by not thinking properly about asynchronicity all the time. Well, suddenly, you've got a chunk of your application where you do not need to think about asynchronicity at all. Reducers are purely synchronous functions. They take, whenever it calls, it takes the state and it takes the action and gives you synchronously the new state. There is no asynchronous logic whatsoever inside of your reducers. And since your reducers are likely kind of to package together some of your most nasty application logic, this is actually kind of amazing, okay? Because you basically we'll still need to deal with asynchronicity, and I'll talk a bit about this, but at least you can banish asynchronicity from the kind of nastiest part of your code where you really are doing sort of data folding. And the other exciting thing is that your data logic now is 100% separated from view logic. I mean, it's so separated that you can't even separate them anymore, right? Because notice that we have not, at this point, talked about our components at all. All we are saying is that we have a state, a representation that has nodes keyed by IDs, and when the update action happened, all we're going to do in our reducer is we're going to figure out which node, which part of our tree to actually needs to be modified in response to that. And you can actually still have modularity by combining reducers. So in that sense, this idea that, oh, it's really scary because now we actually have this giant state for the whole application, it doesn't end up being so bad in practice because your reducers are only going to be processing a subset of your state. And this is the most exciting thing probably, is it creates a whole bunch of opportunities for tools. And let me just do a quick demo on how that works with a very simple application. It's so simple that there's even nothing to see there. No, I'm just joking. So it's this application. It's just a sort of toy note-taking application that all of the examples I've shown you were from this application. And what we have here on the side is the Redux dev tool. So it's basically a panel that you can plug into your application, right? And you could sort of, I can hide it, or I can, where is it? I can hide or show it, but, and even so, I've just reloaded my application, so let's look quickly and see at what already happened. So basically, what we see here is a history of actions, right? And notice that the exciting thing is that our application is now in some ways very simple because nothing changes except in the view except through actions, right? Like if you want to know how we got to where we are, you need to go and look at actions because the components here, they are just a reflection of the application state. So what we see here is that there's some actions that happen before we even touch anything, right? And this is common in Flux. You will actually trigger some actions automatically. In this case, we've sent a request to get a, basically groups of nodes, and we see that one of those this request came back, and we can see what exactly happened, right? So we had a action. And the payload for this action consisted of those two groups, and then here's the data we got. They are keyed by ID, and there's foo and there's misc, and so this is what we got back. And we can now see what's the state, how did this affect our state, right? And so here's the new state that we ended up with, where we have now here two stacks, and what we can see immediately. Let's go back to how was our application before that action came through? Well, let's look. So we have before our previous state, there was nothing there. There was an empty array, right? And now that we folded this action, the new information that came, now that we folded it in, we can see that we now actually have two items there, right? So if we are wondering about, so we don't even need to look at the UI to actually know that our application is processing our data correctly. Now, the other exciting thing that we could do is we could actually say, well, let's imagine this last action, we know we got it, we know it happened, but let's pretend it didn't. So I'm just going to go and cancel it, right? And you can see immediately what would be the state. So essentially, there is a bunch of things that happened in my application before in the split second as it was loading, and now I can actually go back to this in slow motion, and I can say, okay, well, what happened is that before the data from the server came back, there were no groups here, right? And then when this action finally got triggered, that's when the state got changed and the buttons appeared, right? So this is exciting, right? Basically, I can go back in time and see how my application reacts to different things. Now, the next thing I'm going to do is I'm going to actually select one of those. And again, so what we can see here is that a new the select stack action got issued when I clicked on the button. And we could ask, well, what would have happened if that action, and then furthermore, afterwards, the request happened, and in response to this request, we got some data back, right? So 3 distinct things happened, and I could now go back and say, well, let's rewind this. Let's imagine the server didn't respond. Then I would be in this state. I would be in the state where I selected the button, and the button is displayed as being selected correctly, so that logic works. But until the data came back from the server, I have no actual items. And now that when I enable them, I get my first node back. So, and I could also see, okay, so what's the relationship between selection and, for instance, in this case, and the display of items, right? So now the next thing, so let's imagine I'm going to create a new node, and again, I see that the add node action got triggered, and I could go ahead and cancel it, and so again, I can go back and forth in time, and the exciting thing is that this tool, among other things, allows you to do all sorts of things in terms of saving those things, committing, and like doing debugging sessions, sharing them between different. A lot of this is possible because your application state is a reduction over a history of action. So you can always go ahead and basically ask hypotheticals like, well, what if that didn't happen? Where would I be now? And you could sort of trigger things back and forth. So this gives you amazing opportunities for debugging. Now let's go back to these slides. Now, all of this works. All of those great things in the tools, they only work. This ability to time travel, it only works if you are actually diligent about not mutating your state, right? Because at every step when your reducers run, your reducer's responsibility is to take the state it had and generate a new state that represents the modified version of this, but it cannot change the state that we already had. Because if you change the old state, then you can no longer go back in time and see how things were before. Now, this is actually a little tricky in terms of how are you actually going to do that? How are you going to avoid mutating state? Well, it's tricky if there wasn't for one library. So we're not allowed to change the old state, but how do we actually keep our reducers honest? And one option is to clone it the object every time. And the Redux documentation, for some reason, kind of guides you as if, I think they want to make things simple, but they guide you towards this assumption that you can get very far by cloning. And it's a terrible option. You really cannot do this in anything other than a trivial application. And so instead, your solution is immutable.js. Immutable.js is a library that just is perfect for that, and it allows you to basically make modifications to an existing generate derived versions of a data structure without actually affecting the data structure that you had to begin with. So the way this looks in immutable.js is, let's say, if you want to actually set a value, you would have some data you call data.setIn. You provide the path to, you basically want foo.bar.buzz to be 42, so you provide the path as an array, you provide 42. It's a somewhat awkward way of calling it, perhaps, compared to just doing data.foo.bar.buzz equals 42, but it gives you an amazing benefit, which is that the data object is not modified in the process, right? So whoever had access to your data object can, if they were to try to pull information out of it, they will get the exact same thing as they would have gotten before. While new data now represents the modified state. So this is the solution pretty much for all of your problems when it comes to actually working with modifying the state without really modifying it. So let me actually based on that, go back to the reducer example I showed you before and see what exactly we're doing here. So we have a function. So when we get the update node content event, we call a function that returns the output of state.setIn, and then what we provide is a path to the data piece that we want to modify and the value that we want to modify it with. So we basically effectively telling it that we want in the new version that we're going to returning, we want state.byid. The value of the payload of the node ID.html to be equal to the new content, right? And again, this ensures, however, that whoever had access to the previous state is going to not have it be modified in any way. So now, next step is how do we connect this to our container components? And this is actually fairly simple. So you would use a library called Redux. Oddly, so Redux itself is actually a library that is, in some ways, it's like tailor-made for React, in the sense that if you're using Redux, then everything, it fits philosophically with React as a glove. But at the same time, it's actually a library that is completely 100% independent of React. It makes no assumptions. You could use it with Angular. We use it with Angular all the time. And so there is an extra piece that you use to connect them, and that's called React Redux. And the way it connects it is you provide two mapping functions, one that maps state to props, and the other one that maps callbacks to props, so the set of actions to props, and you call that on your container component, and it basically hooks it up in exactly the way that I mentioned before, right? So from your containers component perspective, you're just getting your data sent into you as props, and you call callbacks on those. So it's your container component works talks to its parent in exactly the same way as your normal, as your smaller containers components would. But at the same time, its parent in this case is going to be actually the state container. So here's how you would write your mapping functions. So in this case, we want to pass our props. So as part of our props, we want to pass an object called nodes. And what I'm going to do here is I'm actually going to make it a simple JavaScript object just to make my components' life simpler. So I will just do the immutable JS magic here to extract the data out of the immutable state and just give my component props as a simple JavaScript object. So I start this by extracting nodes, my collection of nodes into a JavaScript object and then ordering them according to the ordering array. And then the second piece is I create callbacks that can dispatch actions. Right? So notice again, so my container is not going to know anything even about actions. Right? It's just going to call callbacks the way any React component would. But what I want to do is I want to make sure that there is going to be a property called onContentChange, which is really going to be a callback. And what that callback is going to do is that it's going to actually dispatch an action. And in this case, the action it's going to dispatch is it's going to get it from a module called node actions, and it will call it with node ID and new content to create a new action and dispatch it. So this actually is all we need to do for the basic case, and the basic case is when your application is entirely asynchronous and it has entirely synchronous and it has no interaction with the server, which is, I'm sure most of you spend your days writing applications that never touch servers. I'm guessing not, right? So let's talk about how do you actually deal with asynchronous actions. Well, you have three options, and I'll talk about them quickly. One is you go with smart action creators. Now that this is the approach that I've briefly outlined before, where your action creators are now going to do more than just simply create JavaScript actions and send them to the dispatcher. Instead, they will actually make API calls or things of that nature. This, I think, is a good approach for when you're starting for your first application. I really recommend go with that route. I mean, it makes it a lot easier to understand how to use Redux, and then when you start realizing the limitation of that approach, you can actually move on to something else. Now, the second approach, and that's sort of going maybe to the other extreme, is using the concept of middleware. Middleware is a really, really powerful concept in Redux, which basically allows you to capture actions and then do a bunch of stuff, potentially issuing more actions, or basically, say, okay, when we get this action, really, we want to do 3 different things. And then the third option is something called React Sagas. And that's kind of a bit of an in-between option. It's a bit more constraining than just writing your own middleware, but it's a bit more advanced than going with smart action creators. So I'll talk in most detail about smart action creators, because if you're new to Redux, that's what makes most sense, I think, to start with. So in this case, the approach is we call an action creator to initiate a request. So again, we call, in this case, the function, update node content, which is going to get passed to our container component as a prop. The action creator function then emits an action to let everyone know that a request was made. So then your components can then update and start displaying spinners or things of that nature. The action creator then actually makes a request. And if the request succeeds, it would emit an action to let everyone know that there's new data. And if it fails, it will emit an action to let everyone know that there was a failure. And the important thing here is that the details of interacting with the server and whatnot really should be pushed into a module. Right? You don't want to be doing this. You, of course, don't want to be making HTTP calls from your component, but you really don't want to be making your HTTP calls from your action creator either. Instead, you want your action creator to call a relatively high-level API. So here's how this could look in practice. We're going to start off by creating a helper function that allows us to have several versions of the fetch nodes action. In this case, we're going to have a version of that action when that displays that lets everyone know that a request was made, and then a version of it that was made where status could mean request is made, or it could mean success, or it could mean failure. And then here is the way we would actually call it. So we'll say when the action creator gets called, we're going to immediately dispatch an action letting everyone know that there is a request, and then we're going to make call fetch data, which is a function that makes an actual call and gives us a promise, and then when the promise resolves, we're going to dispatch an action letting everyone know that there is a success, and if it fails, then we're going to dispatch an action letting everyone know that it failed. So that's the most straightforward approach. You kind of end up with a lot of asynchronous logic using promises inside of your action creators. Hopefully not too much, because you've pushed the really ugly bits inside fetch data, but that's the approach that I would recommend everyone to start with. The second alternative is React's middleware, where middleware is basically a function that allows you to capture actions and then to do additional things. You capture them before they get to reducers, and this could include things like API calls, among many other things. And really, with middleware, the sky is the limit in terms of what you could do, but it's, I would say, a little too generic for many cases, and I don't recommend starting there. And then finally, and I'll talk very, very briefly about this, there's a very exciting approach called Redux Sagas, and it's basically a pre-existing middleware that is using generators. And it's absolutely awesome if you understand generators. How many of you have worked with generators before in JavaScript? Okay, so so if you're new to generators, I wouldn't recommend sort of bundling learning Redux with learning generators, because generators are super powerful, but they're kind of weird too. You can do in very complex workflows in quasi-synchronous way, and it's all very new. So this is like new as in they went from 0.6 to 0.9 in the last 3 weeks or something like that. But here's how it looks, and if it looks weird to you, then I would say pace yourself and get to this a little bit later. But if you've worked with generators, then this is just absolutely amazing, because what we are doing here effectively is that there's no .then. We're just writing a function that is basically listening to requests, and every time it gets a request, it makes calls. And the logic here is almost quasi-synchronous. I mean, it's quasi-synchronous because what happens with yield keyword is that this is a moment where your JavaScript engine basically says, okay, well, I'm going to actually then give the value back to the caller. I'm going to wait until they give me the next step. So you can basically yield a promise, and whatever is on the right hand, on the left hand side of your of your equal here will only get the value that the promise resolves to when the promise actually resolves to. So again, this is really amazing, but at some point look into generators, and then this would be super exciting. And finally, testing. Testing is super easy because all you need to do for testing is you create a state, and then you run it through a reducer by supplying it an action, and then you verify that the value that you get back from your reducer is what you expected. I mean, it's really like testing could not be easier than that. Because your reducers are pure functions, and testing pure functions is super easy. So finally, nothing is perfect. There are some caveats about Redux, based on my experience. One is that it's addictive. Second is that you won't be happy using anything else, which may be a problem with your employer. Your employer may not be on board with you using Redux, and you might get fired, and then you're going to come and blame me. So I just forewarning you. And finally, your friends may not just understand why you're so obsessed with it. And so keep those caveats in mind, but still explore Redux. And thank you very much.